Hello, everyone, and welcome to another episode of, well, a Minitab episode of Fun Times in Statistics. So today I'm going to be looking at some data which you see on your left that I already have open for your notes for this case study that we have this week. This is the donor profiles file, which I've described each of the variables below. This is very typical for your Minitab assignments. It's important to notice that I have a lot of categorical variables floating around here and some numerical variables as well. So we've got a good amount of interaction here. I wonder what's really going on. Let's investigate. So what we hope to do here is we want to figure out how much people donate on average and what factors might influence those donation amounts. So the following confidence intervals we're going to write, and then we're going to interpret them. That's about it. Okay, so let's get into it. So the first thing I'm going to do is find the confidence interval for the mean amount of money donated during the last campaign. So this is just a basic confidence interval. Since I don't know the standard deviation of the sample, this is going to be just doing a regular old confidence interval. And well, in particular, it's going to be a t and not a z, since I don't know what that value is, the standard deviation of the population. So we're going to go ahead and go over to stat, basic statistics. And then to the one sample t. Now the rest of this is for the mean, but it just has ... on the Minitab directions. And again, this is because I don't know sigma. I don't know the population standard deviation. So I'm going over to stat, basic statistics, one sample t. Not z, t. Woo! Okay, so one or more samples in each column. That's true. My data is right down here. I'm going to be looking at amount donated. So I've got a bunch of zeros in here. I hope you noticed that. So I'm going to put amount donated in there. The next thing I want to do is I want to check my options to make sure those are set up okay. And I'm hoping you notice that this is slightly different from the one proportion test. There isn't an option to make it look like a normal approximation, because when we're dealing with means, it's always going to be normal. The important things to notice here is that it's set to a confidence level that I want. There is no confidence level listed here, so we're just going to go ahead and do a 95%er. The other thing is I want this set to be a not equal to for the alternative hypothesis, because that will produce both ends of the interval, just like it did for the one proportion test. I'm going to hit OK, and then I'm going to hit OK again, and that's going to give me my amounts. So here's my results, which I'm just going to, well, I want to go over what all of these are so that you know what they are for the future. So the standard error for the mean, it shows up right here, and that's just the standard error. It's, you know, that guy. The standard deviation from the sample is found right here. So if you're, I suppose that might be kind of confusing. Let me pause real quick and pull up my calculator. Okay, I have my calculator up now because I wanted to show you something really quick in case we're wondering, why are there two standard deviations up here? So the standard deviation you're seeing here, the 5.262, that's actually the standard deviation of the sample. So if you would instead went over to amount donated and just did your stat, basic statistics, display descriptive statistics, and asked it to produce a standard deviation for you, that's the number you'd receive. So that's the standard deviation of the sample. That's S, as we've been calling it. But that's not the standard deviation of the sampling distribution. The standard deviation of the sampling distribution, you would normally calculate by hand. You'd sit there and you'd look at S, which is that 5.262, and then you divide by the square root of the sample size, which luckily they gave us. It's 916 people. And what's interesting about this is you're going to notice that the number this is going to produce shows up over here somewhere. Oh my gosh, that's the standard error for the mean. Just like what I was saying before, this is the standard error, aka the spread of the sampling distribution. That's the spread that's being used to calculate your margin of error and to come up with your confidence interval. So I'm going to go ahead and shrink this for later. So there's my confidence interval. Hey, let's actually, you know, like interpret this confidence interval. So we notice that our confidence interval is 0.552, 1.234, and that seems kind of low because it tells us that we are 95% confident, because that's the one I chose. You could have chosen a different value, by the way, that the amount donated on average for, oops, the last campaign was between, oh, I just spelled campaign wrong, sorry, campaign. And I would be careful, remember we want to include our units, so since this is in dollars, I'm going to write $1.55, which looks a little weird, so it's about 55 cents. You could have used cents here, but since the other one's going to be in dollars as well, I want to keep them the same. And $1.23. And I'm rounding so much here because this is money. I would round differently. In fact, I wouldn't round at all given the choice, but since it's money, I'm going to round these both accordingly. And that seems fairly low. It seems like almost nobody donated anything on average. So it doesn't seem like this is a good representation of really what's going on with our data. And that's exactly what's going on with number 2, is I want to do a better job. If you look at what I've got in number 2, I'm looking at this and saying, well, that doesn't seem very good. I only really want to look at the people who actually donated. So if I want to consider just the individuals who donated, I need to find a way to sort them out of my data. So that's what I'm going to do. So I'm going to be using something called subsetting to do so. So I'm going to sort my data so that I'm only looking at individuals who actually donated and then looking at their confidence interval, how much they donated. So you'll notice looking at our data that there is a column that indicates that, hey, 0 did not donate, 1 did donate. So I'm going to go ahead and pull off those people using the C6 column. So I'm going to go up to, let's see, data, and then I'm going to subset my worksheet. Now, you could do this by doing split worksheet, split the donated off the non-donated, and that works just the same, but I'm going to choose subset this time because I really don't need both of them, I only really need one. So we're going to data, subset, oh, I didn't type that. Data, subset, and then we're going to make some selections. So data, subset worksheet. And now we're going to have to tell Minitab how I want to select these off. So in looking at our coded values up above about what our data looks like, we want to make sure we get only the people that were a 1 in donated last column. So we're going to use rows that match the condition, include only rows that match the specific condition, and I'm going to go to the column and select donated. And then it asks you, well, which of these do you want? Well, I only want the people that are 1s, because those are the ones who have donated to the last campaign. And if you want, you can name this worksheet, and I'm going to call it donated only. You could call it something else. If you don't put anything here, Minitab will automatically name it for you. Fun times. And sometimes the names are a little weird, just so you're aware. All right. Now, you've got 2 worksheets floating around. This is the first time this has possibly happened to you. I would suggest you be careful at this point because since there are 2 of them floating around, you want to make sure you're in the correct one for doing your data analysis. So I'm going to click on the old one, the donor profiles one that has all the data, and I'm going to shrink it so I don't accidentally click on it because I only want the donated only people. So you have to be careful. Oh, I just double clicked, sorry. Window, and then tile. There we go. Oh, now my session window's on the bottom. What are you going to do? Anyway, so my donated only pile is now on the top, yay. But in particular, it only contains people that donated. Notice all this is 1s and I only have dollars here. So now I'm going to do the confidence interval again. So I'm going to just be lazy and copy this because that's how I roll. To come up with a confidence interval that represents only the people who donated. So we're going to go up to stat, basic statistics, 1 sample T. And I'm still doing this for amount donated. And I'm going to go ahead and do the same options as I did for the other one. So I can kind of look at these and say, oh, if I only look among donated people, this is what the average is. So, yep, 95% not equal to. We are good to go. Let's go ahead and go through our OKs. And now we have a different confidence interval. So I'm hoping you look down here and see it's like $13 and $22 instead. So let's make that interpretation using that information. We are 95% confident that the mean amount donated, having all kinds of typing issues today, in the last campaign when only considering the donors is between $13.03 and $22.53. So I want to be very specific. I'm only looking at those who donated when they were doing the campaign, because our previous example only included everybody who they've ever asked for money. So keep that in mind. Yep. So if you were a little worried about how there's not a big difference between these two, so you could say amount donated on average for the last campaign was between da 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 da, when considering all individuals contacted. That way it's clear that, yeah, I included a bunch of zeros from the other one. So there's that. Okay, let's look at number 3. So here we're interested in looking at donors. Oh, sorry, you might want to take a minute to read this. Among those who are known to own a home, find the confidence interval for the mean the amount donated during the last campaign. Compare this confidence interval to the mean amount donated during the last campaign by those whose homeowner status is unknown. Uh-oh. So I need 2 groups that I need to compare here. So I need to do this twice. So I'm going to get rid of my donated only set. Boop, and bring up my original donor profiles. And then I'm going to have to cascade this again, or sorry, tile this again so it shows up right. So this is my original data. And I want to look at both people who own a home and those who don't. So in this case, since I'm going to have to do this twice and I need to pull 2 things or more than one thing off of my data set, instead of using subset, I'm going to be using the other option, which is what's called a split. So it's going to produce 2 worksheets for me. So we're going to be going to data and then split. And I'll show you what a split looks like now. So we're going to go to data, split worksheet, and it asks you, how do you want to split this? Which variable do you want to split by? Well, we want to split by homeowner status. Let's go ahead and put that in there. And I'm going to ignore this missing by level thing because this has no missing data in it. But if you did have a missing data piece, that's wonderful. Go away. You would have to include this just in case. And that would give you another category to look at. So I'm going to go ahead and hit OK, and it brings me these 2 pieces of information. So you'll notice I now have a bunch of worksheets on here. One that's homeowners with a U and homeowners with an H. These are people that actually own homes, and these are people that it's unknown whether or not they own homes. So there we go. So we're going to take these 2 groups and compare them. So we're going to go up to stat, basic statistics, and then the one sample T, amount donated still. My options are still the same. I'm going to go ahead and hit OK. So I'm doing the H group now because that's the one I have highlighted. So be careful in here as you're looking at this. It says it's letting you know where exactly it did this. The results for your donor profiles for homeowner equals H. So I'm going to say that I'm going to do a little summary right here for homeowners. My interval, not sad face. Sorry, it's kind of funny. I'm sad about donating. It's okay. At least it wasn't blood. Yay! So I have that summarized right there. And so I'm going to do this again for the unknowns. And then I'm going to compare the 2. So now that I'm done with the homeowners one, I'm going to go ahead and minimize it. Why is that so long? That's super weird. And now I'm going to click on the U grouping. That way that's the one highlighted, and I'm going to go through the same steps. So I'm going to go back to stat, basic statistics, and down to one sample T to produce my confidence interval. I'm using the same setting, so I'm just going to hit OK, which is a little shady on my part, but I'll have to be all right. 0, 4, 6. And 0.853. So a couple things to notice. They overlap. When they're overlapping, this doesn't tell you that there is any difference between the groups. Overlapping means it is quite possible that the behavior is the same. On average, they donate the same amount. So since they overlap, it is possible that the amount donated is not different. Or you could say is the same. I'm going to say is the same for these two groups. That's pretty vague. This tells us that whether or not someone is a homeowner is not I hope I can cut that. Sorry. This tells us that knowing whether or not your donor is a homeowner doesn't change the amount they donated on average. That the average donation received from individuals who own a home is not higher, because you might suspect you're a homeowner, you have more money, than other groups, than those who don't. Let's say that. So if you want to think about it as who's a contributing factor to cause people to have greater donations, homeownership seems to be doing nothing. Homeownership appears to be telling nothing about what's going on in this campaign. That's unfortunate. Let's look at gender. Yay! So now we want to compare the confidence intervals for the mean amount donated based on gender. So we're going to do this again. So I'm going to take and get rid of this one. Woohoo! Okay. So once again, I am going to need to go ahead and split my data by gender this time. So we're going to go back up to data and then choose split. And I don't want to split by homeownership anymore. I want to split by gender. And I'm going to hit OK. And I'm hoping you notice that I have a third category, unknown, as in whoever was recording this data didn't do a good enough job because they missed a group of people, or they just didn't ask. So I'm going to have to go through and do 3 confidence intervals, one for U, one for F, and one for M. I hate the smiley face thing, or sad face thing, probably because it's a sad face. Okay, so I'm going to do unknown first, so I got to highlight that. So notice this is slightly darker in text and slightly darker in color than the other two. We're going to go up to stat, basic statistics, 1 sample T. I would say this is the only downside to Minitab. I'm going to have to do this 3 times, so I'm going to do it in quick succession and then copy them over. So I'm going to hit OK. Go back to my data. I'm going to do males first. Stat, basic statistics, 1 per 4. Oh crap, I just did the wrong one. I mean, oh no. Oh phooey, I burned the darn muffins, or something appropriate that's not going to make people write terrible things about how I swore. Anyway, let's hit OK. Males, done. Last but not leastly, let's get the ladies up here. Stat, basic statistics, 1 sample T. There it is. Let's hit OK, and whew, who's tired? You's tired? I'm tired. Let's get them all typed up here. So let's see. The female one's my bottom one. That's 0.409, comma, space, 1.109. And then next up I have the males, so 374, comma, space, 1.109. These are looking very similar. I just put the female one in the male one. Whoopsie doodles. Let's do this. 6121. And then unknown. Where's the unknown guy? I gotta scroll up a little. Oh, that one even goes negative. Well, you can't undonate money. You can't make negative values for a donation. So I'm actually gonna put 0 here because you can't get below 0 when it comes to donations. And that one is just so variable that I'm a little terrified. I don't know if I can even use that result. Its spread is huge. It's from 0 to 6. These are all smaller than 1. That to me says that this result is probably not as useful. And one of the reasons why it's so off is the fact that this has such a small sample size compared to the other two. So as we go further in this class, I'm going to have better ways of looking at this than just doing a bunch of confidence intervals for no reason. We're going to have things like, oh, is one of these groups have a different mean on average? And we'll be able to answer this question better. That's actually called an ANOVA. So unfortunately, that's one of the last things we learn how to do. But if we only have two groups, like the homeowners and the unknowns group up above, we actually are going to have that test literally next week. So what do I do if I have two groups? Oh, well, you know, there's some options, but we'll literally know how to do it next week, and we'll have better ways of seeing this. So the first thing I'm going to note is, since they do all overlap and overlap quite a bit, you can't really tell if there's a difference among these groups. However, it is worth noting that the unknown category has a huge spread above the rest of them, and therefore is, you know, significantly different from the other two. So we notice that's so small it's going to be hard for you to read, so I'm going to make that bigger and bolder. Okay. Note, we observe that the unknown category has a significantly wider spread and is very different from the other group. Additionally, the male and female donation averages they overlap almost entirely, so I'm going to say that. Averages overlap almost entirely and are likely to be very similar for this reason. So you're able to look at these three groups now and say, hey, who's different? That guy. The other two are pretty much the same. So this is a little unusual because you're able to say, like, oh, the two genders that we know, they behave similarly. So there's no difference in donation amount based on gender. However, if we look at the group that we don't know what the heck they're doing, or I failed to gather enough data about them, they appear to be significantly different from the other two groups, which is a little unusual. All right, so lastly, let's compare the confidence intervals for the mean amount donated based on wealth. Now, I don't know if you've looked at the wealth category or you remember from looking at our data up above. Well, there's a lot of wealth categories to choose from. Like a lot. So, what I'm going to do is I'm going to just pick two wealth categories. So, I'm going to scroll up for a second, so don't get dizzy by this, I hope. Wealth category is something from 1 to like 9. So I'm just going to randomly pick two. I'm going to pick, well, let's use two. I'm going to split off two values sort of randomly. So I'm going to go back up to data and then split worksheet. No, not split worksheet because that'll give me all of them. Data and then subset worksheet. And then I'm going to select, rather than donated this time, I'm going to choose the wealth category. So I got all these to choose from. I guess I'm picking 2. I guess I'm picking 7. All right. Oh boy. Here we go. 2 and 7. Okay. So here's where you got to be careful. This has both 2 and 7. And I'm going to do the means for 2 of these. So now I need to split this into just the 2s and just the 7s. So now I'm going to go back up here and split the data by, where is it? Wealth, because my wealth only has 2 values in it. Ta-da! Now there are other ways you could have done this. I chose to do it this way. So here's my group for 7. Let's go ahead and do that. Why is my L not? There it goes. Juice. So this is going to be my wealth equals 7 category. And then I'm also going to have my wealth equals 2. Here's an L for fun. Okay, so let's go to 7. So here I'm going to go to stat, basic statistics, down to one sample T. Yep. You know what, for fun, let's do a different size confidence interval. Let's be a little, I don't know, less confident. Or do I want to do more confident? Let's do less confident. Let's do 90 for fun. So there's my confidence interval for 7. Again with the sad faces. Okay. And now let's do wealth equals 2. So I'm going to click over onto the 2 guy. Wealth equals 2. Yep, this is the right one. Okay. So I'm going to go to stat, basic statistics, down to 1 sample t. I'm going to check to make sure this is still a 90%er so that these are both the same percent, or the same level of confidence. Let's be more specific. Alrighty. Ooh, this one went negative. I'm gonna, oh, the negative is so weird to me. Negative 0.348. And by the way, certain people, when you encounter them, especially if you're dealing with something where negatives make no sense, we'll just make this 0. And that's perfectly acceptable in statistics, by the way, because it makes sense for you to donate $0. It makes no sense for you to ask this charity to give you 35 cents. That's just crazy town. Okay, so what do we notice? Well, I would say they overlap, so it is quite possible that they behave the same way and wealth means nothing. But in particular, I would say that the category 7 for wealth appears to be, on average, donating more. Whether or not it's significantly more and they're different, that's something we need other things to be able to tell. So, you know, clearly one of them has a larger margin of error than the other, and there's a little bit more spread involved for the wealth category number 2. But overall, wealth category number 7 has more spread. I'm looking right here at the standard error for the mean. The spread is much larger than that by almost double. So there's that. I also have a much larger sample size for the wealth category 7 than I do wealth category 2, and that might be contributing to how different these are from each other. So a couple things to say. Since they overlap, they may be the same on average. However, their spreads, I can even say margin of error because, well, the margin of error just multiplied by those two, and it's multiplied by the same number. Margins of error are different by a factor of almost 2, so it's almost twice as big. Let's go by almost double. That's a little clearer and easier for the average reader to understand. So it makes sense that there's a significant difference in spread here. So one of the things that's kind of untrue here is you can't really say, yes, they are significantly different because they share things in common. My mean could be in both of them. Like if my true mean amount donated amongst the population was 0.58, that's in both of these, so we're good. Even up to $1.34 is in both of them, so and not below 44 cents-ish. So we don't necessarily know the population mean going in, but we do know that since these overlap, they might end up being exactly the same and that there is no difference between them. So the only concern I really have here is that their spreads are so different that that usually indicates that they're behaving a little bit differently. So this is normal how you compare these. Centers, spreads. We don't know shape. So that's also how you used to compare graphs when you were doing stat 1. So keep that in mind. Do they have the value in there, and how do their spreads look? Look at their margins of error. It is sufficient for you to just look at their standard errors to be able to tell what's going on. Since I use the same confidence level, they have the same multiplier to make the margins of error. So that's why I can say margin of error is about the same, or is different by almost double. So I'm concerned about that. I'm really getting antsy in my pantsy about this, but the second we hit 2 sample testing, you'll be able to say, oh, well, let's actually do a test. Are these two significantly different from each other? And we'll be able to do that. Ooh, I rambled on a little bit at the end. Okay, so that's all I have for you for means with confidence intervals. Hope you enjoyed it.